Hello students and welcome to class. This is your flipped lesson for lesson 2-8 in your Glencoe Algebra 1 book, which begins on page 126. Your learning target, please make sure you get this in your notes. I can solve equations for given variables, and I can use formulas to solve real-world problems. Your vocabulary terms, literal equation, dimensional analysis, and unit analysis can be found on pages 126 through 128. Please be sure you read the highlighted and bold print terms in your book and see if you can come up with a good, in your language, definition for these terms. Previously, when you solved equations, the type equations that you see here are the type of equations that you solved. Pause the video for just a minute or two and try these problems to see if you still remember how to solve one. Remember, when you're solving equations, the goal is to isolate the variable. Get the variable all by its lonesome. To do this, you use sort of the reverse of the order of operations. You know, the order of operations, parentheses, exponents, multiplication or division, addition or subtraction. Well, we're looking for addition or subtraction first, and we're going to undo the order of operations. First off, let's add that 3 to both sides because it is the opposite of subtraction. 3's gone from the left side of the equal sign, and I am left with a negative 7x equals 21. Now the coefficient negative 7 of x and that x smushed together means the operation of multiplication. Think, what is the opposite of multiplication? I hope you answered division. Represent division with a fraction bar, and we divide by exactly the coefficient, which is negative 7. And hopefully you got the answer, x equals negative 3. The other equation, notice that you've got variables on both sides. We have to get those variables together, and we have to get the constants together. Let's start out with getting the constants together. The opposite of subtraction. Now I'm going to move things around. Since that 3x is a larger coefficient of the variable, I'm going to leave that 3x where it is. And I'm going to start out moving that negative 5x. Do so by doing the opposite, which is adding 5 to both sides. 5 is gone from the left side of the equal sign, and I'm left with 3x equals x plus 12. Next, I need to get the variable terms together. Although we don't see it, there is an imaginary 1 in front of that x. I need that x to move over to the left side of the equation with the 3x. Since this is positive, I perform the opposite operation, which is subtraction or negative. Then I'm left with 2x equals 12. Just like in the previous problem, the last thing I have is multiplication, and the opposite of multiplication is division. So now I'm ready to divide both sides by 2 and get my solution, x equals 6. Make sure if you do not understand these that you write these problems into your notes, as well as if you missed working one, write down how these problems were worked, bring your questions back to class, and we'll take care of those. Let's change things up just a little. Now I have an equation with two variables, and I want to solve this equation for W. So I will be isolating the W to the left side. Since it's on the left side of the equal sign, I want to isolate that so it'll be all by itself. Well, the first step, I need what's on the side with the 5W to move. Since there is addition represented and the opposite of addition is subtraction, I want to start out by subtracting the 12C from both sides. Why do you suppose that I wrote that minus 12C out from under the 9? Look closely. Are they like terms? They're not. Since those are not like terms, I wrote it out from under so I would not make the mistake of trying to combine unlike terms. The 12C is gone from the left, and I'm left with 5W equals 9 minus 12C. Solving for W, I am left with the operation of multiplication, just like I was in the other problems. And in the other problems, the opposite of multiplication is division. So I'm going to divide the whole thing on the right. Both terms on the right, your constants and your constant and your variable term. Divide that by 5. My 5 divides itself out on the left side, and I'm left with W equals 9 minus 12C divided by 5. Now you may look at this and be thinking, wait a minute, did we really solve that for W? Do we know what W is? Well, we actually do. We can't do anything else at this time. Be sure you write this problem down in your notes. Ask questions in class if you have any. Here's another problem that's just a little bit more challenging than that previous problem that I worked with you. Pause the video, give this one a try, see if you can figure it out. Let's take this one step at a time and solve it together. First off, we're solving this for x, which means I've got to get all the terms with x on one side of the equal sign and everything else on the other side. Let's start that by, since this x has a coefficient of 7, which is larger than the coefficient of the other term with x in it, here. Let's move this negative 2x or minus 2x opposite, adding to z, I think I said x, adding 2z to both sides. Now remember in the previous problem why I put that out from under everything else. There's no like term, and I don't want to get mixed up and try to combine something that is not like. So my 2z is gone, and now I have 7x equals 4 minus xy plus 2z. Okay, now I got to get that minus xy, opposite of subtraction, addition. Now, you may be looking at this problem and thinking, now why did Miss Crumpton put that minus xy out from under the 7x? For this reason right here. That's an x. That's an xy. They are not like terms, so I can't combine them. So now I have 7x minus xy equals, of course it's gone from over here now, 4 plus 2z. I want you to take a close look on the left side. Do I have a common factor in each of those terms? Have you found your common factor? That common factor is the x. So what I can do is factor out the x, or undistribute the x. So when I undistribute that x, then everything else is left behind in parentheses. Now I want to think about that 7 minus y that's in parentheses. I want to think about that as a coefficient. And x would be multiplied by the 7 minus y. What is the opposite of multiplication? The opposite is division. Now I'm going to have to go up to the top to keep this all on one page. So I've got x, 7 minus y, in parentheses, equals 4 plus 2z. Okay, thinking about multiplication, the opposite of multiplication is division. So I'm going to divide by 7 minus y. Divide both sides. What you do on one side, you got to do to the other. Now you have x isolated. You have x equals 4 plus 2z divided by 7 minus y. Wow, what an answer. How did you do on that one? Look back over each step. If you have questions, please be sure you write down this problem and all of its steps. Bring the problem to class so that we can discuss it. Here's a real-world problem for you to try. The formula a bricklayer uses to estimate the number of bricks to construct a wall is N equals 7L times H, where N is the number of bricks needed, L is the length, and H is the height. Suppose the bricklayer knows the number of bricks he has as well as the length of the wall. Solve for a literal equation that can be used to determine how high the bricks can be laid on the wall. We're told that the formula is N equals 7LH. We've got to look at the 7L as though it is a coefficient. And all of this represents multiplication. A whole lot simpler than what it looks. What's the opposite of multiplication? Division is right. I divide both sides by 7L. And I get that H equals N divided by 7L. Interpret what that means. The height can be found by dividing the number of bricks by 7 times the length. In the previous problem, we determined that the height of the wall can be determined by the number of bricks divided by 7L. In this problem, we're asked, suppose the length of the wall to be bricked is 30 feet long. The number of bricks available to use is 2,310. How high can the bricklayer lay bricks? All this is a simple substitution problem. Replace n with the number of bricks given, which is 2,310. 7 times the length. And now all we've got to do is a little multiplication and division. We will have 2,310 divided by 210. When you do that computation, you should find the answer is 11. Now let's do a little dimensional analysis. You'll also be using this in chemistry and also in science class with Miss Cater. Suppose that you go somewhere and you weigh, but their scale is weighing in kilograms, and you would like to know how much you weigh in pounds. Well, we can do this by a dimensional analysis. We want to start out with the units that you were given. 52 kilograms. Now, I may do this a little differently than Miss Cater does, but I'm going to make this little table. Now, if I'm trying to convert to pounds, I want to end up with pounds on the top of this line that I've drawn. Okay, now I know that there's a relationship between kilograms and grams, and I have information here in the hint that 1 gram is 0.0353 ounces and 1 pound equals 16 ounces. So if I can work that in some way, I can figure out my weight in pounds. Okay, so 52 kilograms. I want to put the kilograms diagonal from each other so the unit of kilogram will cancel out. And I know that 1 kilogram is 1,000 grams. Okay, that is going to get rid of my kilograms. Kilograms are gone. And now I'm left with the measurement of grams. Okay, now my little hint up here, again, I don't want grams. I'm not interested in grams. I don't care about grams. But I am told that 1 gram is 0.0353 ounces. Okay. Now, my units of grams cancels out. Now I'm one step closer to where I need to be. I know that from the hint, there are 16 ounces in a pound. So I want to get rid of the ounces, OZ. I put it diagonally, and I put my 16 here. 16 ounces equals 1 pound. And I make my L cursive so it doesn't look like a 1. Now my ounces cancel out, and I am on my way to an answer in pounds. I don't need the rest of this line here, so I'm going to erase it, write in an equal sign, and I simply do my computation. I'm going to end up in the unit of pounds. Now when I multiply 52 times 1,000 times 0.0353 ounces, I get 18,300, let me try that one again. I get 1,835.6. Okay, I know 1 times 1 times 16 is simply 16. When I divide that, I get that my weight in pounds is 114 pounds. Of course, I got a decimal number after that. So I can round that up to 115 pounds. The mental analysis is not that hard, and you will find yourself using this frequently in the real world, especially in Miss Cater's class and in chemistry. Now it is your turn to try a few problems. These problems, in case you can't see the picture very well, they come from your Glencoe Algebra 1 book, page 129, and I would like for you to try problems 8 through 19, all of these problems. Be sure if you have trouble with any of these, which I don't think you will, go back and look at the notes that you took from the video, follow them carefully, give these problems a try, and guess what? I will see you in class. Have a great afternoon.